Let's recall this result from Terence-Tau's analysis. What it basically says is that between two distinct real numbers, there is a rational number. If x and y are real numbers such that x is less than y, then there exists a rational number q such that q is greater than x and less than y. Say we want to prove a similar result where we replace rational number by irrational number. There exists an irrational number r between x and y. How can we prove this? If you think of this, at once it seems like a very complicated task, but sometimes already established results can be used effectively to prove something new. Obviously, if they are related. So let's see what we can do here and how we can use this one to prove this one. Since x is less than y, we have x minus square root of 2 less than y minus square root of 2. That's true. You subtract something from both sides of an inequality, the inequality remains intact. Remains intact means it does not get reversed. So, by this proposition, five, 4, 14, there exists a rational number q between these two numbers. Oh, and why are we able to apply the proposition here? Because x minus root 2 and y minus root 2 are after all again real numbers. Such that x minus square root of 2 is less than q, which is less than y minus square root of 2. So adding root 2 throughout, we will get less than y. So we seem to have obtained a number q plus root 2 between x and y. But is it irrational? It is actually irrational. Why? Note that q plus square root of 2 is irrational. Otherwise, had it been rational, this also would have been rational. Square root of 2 would have been rational because that's just the difference of this and q. But we already know from number theory or elsewhere also, you don't need actually number theory. We know even before getting number theory that this is irrational, and that is why this cannot be rational. This is an irrational number. So why I chose to discuss this is that sometimes statements which at once may seem very complicated to prove may actually turn out to have some easy proof when you use some already established statement. You just have to think for a moment how to use something effectively. So that takes away all the complexity which initially you may think this R will have. You just have to produce one R. Whenever one thinks of that result which talks about a rational being between two real numbers, the focus is mainly on the rational number. But one often forgets that the other two numbers are any real numbers. So they can be used to create a situation where ultimately we can manipulate things so that we can create an irrational number even from a rational number. Okay. So that's just what I wanted to say. The main point here is not this result or that result. The main point here is that sometimes things do have simple proofs. If you know how to use an already known result nicely. So that's just it.